Anyway, hello friends, in this video we will talk about hemoglobinopathies and hemoglobin derivatives. So first hemoglobinopathies and the hemoglobin derivatives. So we will discuss two hemoglobinopathies, sickle cell anemia and thalassemia. We'll first start with sickle cell anemia. So what is sickle cell anemia? You're seeing in this picture, the RBCs will become sickle shape like this. Okay, you're seeing sickle shape. Okay, that is HBS. It's a S as in sickle gene. So what is happening in sickle cell anemia? Glutamate will be replaced by valine. Please note my words from here onwards. Glutamate is replaced by valine at beta 6. That is 6th position of the beta chain. Okay, right. So HBA becomes HBS. GAG becomes GUG. So adenine के place में uracil आ रहा है. Okay. Now let us see with homozygous and heterozygous sickle cell anemia. So gene pair and feature, we will describe two aspects. So what is the gene pair? Homo is similar, hetero is dissimilar, different. So there will be two HBA genes. Okay, A as in the anemic gene, heterozygous HBA and HBS. So only difference will be here in place of HBA, HBS. Okay. What an important feature we will see? Homozygous, those who have homozygous, they will have lifelong anemia. They will give it to their generations. That means if father has it, his son will have it, his son's son will have it, and like that it will keep transmitting. Okay. Heterozygous, they will be normal, but they are silent carriers. Okay. Right. Let's see the abnormalities with HBS. Lifelong anemia, early death, tissue damage and lowered immunity. Same happens in HIV and AIDS. Even you might have observed HIV and AIDS also the immunity is significantly lowered. There the thing is their B cells, T cells, cytotoxic cells, those functions will be impaired. Here it is regarding HBS. Okay, try to understand this point. Now here you can see the formation of the sticky patches in the hemoglobin in the HBS. Okay, so this is oxy and deoxy HBS, same with the HBS. So like this you are finding that these segments are joining to form the sticky patches. Okay. Now sickle cell trait protects from malaria. This is known to give malaria resistance. You might have known from your basic biology classes. Malaria requires what? RBC for the lifespan, is it not? Okay, so it requires RBC to start its cycle. If the RBC itself is having fragility, how will the malaria start its cycle? Okay, so when there is a sickle cell trait, you are observing there is no multiplication of the parasite because there is the RBC is lysing and its fragility is more. Where will the plasmodium cycle happen, right? That's why malarial resistance. Now electrophoresis. If we take an electrophoresis, you are observing that the HBS is moving faster compared to HBA. Remember, always the diseased one will be always the diseased one will be more prominent compared to the non-diseased specimen. Okay, this is at a pH of 8.6. Okay, let's see some other hemoglobinopathies before we move on to thalassemia. Okay, so we are seeing other hemoglobinopathies C, E, D, M. Okay, HBS I told you, beta 6 glutamine replaced by valine. Okay, so same with HBC, same position, but amino acid is different. In place of valine, lysine. Okay, and HBE in E, C is called Cooley's anemia. Okay, E is involving beta 26. Here 26 is important. Same thing as that of HBC. Okay, differences at which position? Here it is 26, here it is 6. Okay, and D occurs in the Punjab. in Punjab and Haryana, northeast, okay. Punjab, Haryana, Delhi, okay. Here in place of 26, 121. And also amino acid change. Here in place of lysine, glutamine, okay. And in M, there is a proximal or distal histidine in alpha or beta chain. Here it is totally different. Histidine to tyrosine, okay. Remember in these four, glutamate is common, okay. In HBC and E, lysine is common, okay. What will be the difference? In HBS it is valine, in HBD it is glutamate, okay. And HBM is totally different from all of these, okay. And another thing, HBS and C are the same position, beta 6, okay. HBE in place of 626, for D it is 121, okay. Let's see with thalassemia. It is common in the Mediterranean population, okay. That point is not very important. Important is what are the types of thalassemia, alpha and beta, two types. Let's see alpha, okay. So four properties: silent carrier, alpha thalassemia trait, HBH disease, hydroxyfetalis. So the gene copies will be in the chromosome 16, okay. Normally all the genes will be there, but in silent carrier, so as we go from 1 to 4, one gene will be lost, okay. So here this is the first one, so one gene is gone, not much symptom, normal. Alpha thalassemia trait, okay, that is a heterozygous. Here two copies gone, minor anemia. In HBH, three copies gone, that is mild to moderate anemia but still normal life. And hydroxyfetalis, severely edemic fetus, okay. Here all the four copies are gone, okay. So early death of the infant, okay. Now let us see beta thalassemia. So the genes for beta thalassemia are in chromosome 11, okay. So we have a major and minor. Major is called Cooley's anemia, okay, or Mediterranean anemia, okay. First we will see the prevalence, inheritance, what is the level of anemia, the basic defect, HbF levels and the lifespan. So prevalence, which is more common, minor, okay. What is the mode of inheritance? Homozygous in case of major, opposite of in minor, heterozygous, okay. Anemia is more severe in major, okay, than that of minor. What is the defect? No beta chain in major, reduced in minor, okay. Then HbF levels, significant in major, not much in the minor, okay. And lifespan, who is having more lifespan? Those who have minor, because it's heterozygous. Remember, those are heterozygous, more lifespan. Those are homozygous, less lifespan, okay. That is about the beta thalassemia. Now let us go with the hemoglobin derivatives. We will see myth and carboxyhemoglobin, okay. So first, myth hemoglobin. What is happening here? How hemoglobin to myth hemoglobin? So by free radicals, the word myth will be added, okay. So conversion of ferrous to ferric, okay. Then reverse happens through reductase, okay. That is NADH2 to NADP plus, okay. Now carboxyhemoglobin or COHB. So remember, carbon monoxide has 300 times more affinity for hemoglobin than oxygen. Where is it coming from? From automobile, it's coming from the automobiles and industries. Very common nowadays. See, whatever the air we are breathing outside is not pure oxygen. Please don't go into that false assumption. Nowadays, we are not breathing pure oxygen. Because of this increased automobiles in our India, there is more pollution. We are not breathing fresh air, okay, nowadays. That's the problem. So we must be more conscious. We must take care of environment. It's very important. Remember always, nature is powerful, okay. Anyway, so now since it has more affinity for hemoglobin than oxygen, when it goes into the blood, it causes hypoxia and instant death. Instant death of the patient, no matter what. And vomiting, nausea also. Okay. That was regarding the carboxyhemoglobin. References from where I took the images. That brings us to end of the video. So thank you so much. I'll see you in the next video.